All right, so Chemistry 30, we're in the Merrill Chemistry textbook, page 604, number 3. But this is a question talking about the KSP, the solubility product constant. And so this one's a bit of a funny question. It says if the concentration of D plus is 2.00 times 10 to the negative 5 molar at equilibrium, what is the KSP of D2A? Now, D and A are not specific elements on the periodic table, so don't be looking for D or for A. But what you want to do is you want to understand that the ratio between the number of moles of D and the number of moles of A in this solution is 2 to 1. Okay, so what's going to happen? We've got D2A, right? And we're at equilibrium here. And so I've got D plus and I've got A minus. Okay, if this breaks up into an ionic, it's an ionic compound, it breaks up. So we've got D plus as mentioned there. Now, notice that in order for this to be balanced, I have to have a 2 in front of the D plus, right? So that means that there's twice as much D as there is A, you see? So if D is equal to 2.00 times 10 to the negative 5 molar, then what is A? Well, A is 1.00 times 10 to the negative 5 molar. You see that? So that's just a simple ratio of the molar ratio of the dissociation equation there. So if I know what these two concentrations are, now I can find the KSP. So the KSP is given by the product of the concentrations. Now we have to set it up appropriately. Remember, I have this 2 here, so the concentration of D plus has to be squared, right? And the concentration of A minus, because it just has a 1 as a coefficient, is just to the power of 1. So the KSP comes from 2.00 times 10 to the negative 5 squared times 1.00 times 10 to the negative 5. Okay? And so you can get on your calculator if you want, there, that's, okay, so we'll do that here. Let's get the calculator out. And we'll turn that on. Remember, when you plug this into your calculator, use your EE button or your EXP button, okay? Use that button. And to the power of 2, okay, is 4. And so you're multiplying this times itself and this times 2, really. So it's 4 times 10 to the power of negative 10 times 1.00 times 10 to the negative 5. And so 4 times 1 is going to be 4. And negative 10 plus negative 5 would be times 10 to the negative 15, looks like. And we'll just confirm that on the calculator, just so you don't have to take my word for it all the time. So I've got this, and I'm multiplying by a 1 times 10 to the power of negative 5. Okay, so 4 times 10 to the power of negative 15. So that's what the KSP is, and of course we'll keep the 3 significant figures that are given in the problem there. And so here's the KSP, 4.00 times 10 to the negative 15. Okay, so that's predicting KSP Chemistry 30.